the result would be the identity matrix. Obviously, we could apply any transformation to this matrix. For example, offset the plane along Z in local space, or assign a rotate X matrix at 45 degrees and offset the position of the sliced plane to pass exactly through the center of the current node multiplied by the inverse of its transformation. Knowing this, we could develop a script which goes exactly the other way around, taking a world space transformation of some object, for example a plane, and modify all the slice plane gizmos to pass through this world space plane in object space. Let's create a new script. In this script, the plane variable is going to contain a reference to the scene object plane 01. We don't have this object yet, so we can create a plane with that name and also create a couple of typical geometry objects, for example a cone, a sphere, a cylinder, a tube, a pyramid, and so on. We could move this plane somewhere in space, rotate it slightly, make it see-through, and now try to take this plane and apply a slice modifier to all these objects. The first thing that we'll have to do is check the current selection. For every object in the selection where the superclass of the object is equal to geometry class and the class of the object is not target object and the object is not the plane itself, we're going to perform the following. First, we'll try to get the modifier from the current object, looking in the modifiers array for a modifier called slice. If this modifier is equal to undefined, that means there was no modifier on the stack yet, we're going to create this modifier, a slice modifier, with slice type set to true. This is removing the top of the object. Then we add this modifier to the object, and in addition we could also try to add a modifier to the same object of the class cap hose. After this, we either got an existing modifier or created a new one, and we can apply the transformation to its slice plane transform property. We're going to take the plane transformation. This is the world space position, rotation, and scale of our plane, and multiply by the inverse of the object's transformation. This way, our coordinate system is being converted into the local space of the current object. At this point, we could try to evaluate this script. First, we'll have to select some objects because the only selected object was the plane.